Okay, in the last video, we added a certain level of interaction to our tile-based game. Now we're going to add some rules around that interaction with the tiles themselves. Okay, so the principle is basically that we are going to check for what tile we are on, other surrounding tiles in a specific directions to figure out whether or not we are allowed to move, which is different to actually using a hit test approach, but it's also going to be more efficient in terms of code. We can optimize this further later on, but what have we got included? Don't need that. So the imports are movie clip, keyboard event, and keyboard, which are consistent from the last. We have the movie clip player. We have the map array, which was practice map, but I've just shortened that down to map now. So all references to practice map are changed to map. You could do that with Control F if you wish, and do find and replace all, or you can walk through and just change the references. So we have a map there. I'll just show you the map and it working. Change the player a little bit to have a little face, and you'll notice that as we're scrolling through, not go into the wall. Let me go off the screen. Well, that just caused, or has caused, some challenges along the way. And so this is basically a tile-based game restricted to a screen, but then what you can do is you can treat it as scenes. So you go from map 1 to map 2 to map 3 and have a transition between the scenes perhaps. Okay, so the maps changed ever so slightly. I've got a new variable called total rows, which we may or may not use. In fact, yeah, we could change this map.length into total rows so that it's not having to calculate the length every single time. There's variables just stored in memory. And again, here we could have total columns. It's an integer, and that will equal map 0 dot length. It's just taking the first row and finding out the length, because if you've done it consistently, then they'll be the same all the way through. So we can then just call that total columns. There we go. And just double check that that works and we haven't broken anything. It's all good. Okay, so I'm using the set location function at the start to position all the tiles, as we did before. We've got the move player function, which is now expanded. We've got a variable called context object. And this object contains the information about what is to the left, what is to the right, what is above, and what is below. And there are some problems with this because we're working with arrays to find out information. But I'm going to create a function called getLocationContext. Once we've got that context, in a very simplistic way, we're checking for if the context object left equals 1. There is some further work we'll have to do on this later on to make it work for more than one tile that we can walk on. But to prove the principle of the concept, then we'll use this. So we're accessing the property left, the right, the top, the bottom, and we're just checking to make sure that not only is a key being pressed, but that we are allowed to move there. If we're not allowed to move there, then nothing will happen when that key is pressed. This could be optimized to a certain extent later on down the line also. So the new function, getPlayerLocationContext, you will notice differs from the other functions in that it's got a little bit of information here. :object. This says it's going to return an object. It returns the object when it's called in this line here. So that's why we are adding the information coming from the function to this label context object so we can access it. And it's just the principle of having modular functions, things that do one job, one specific function, and then you can reuse them. So what we've got, we're creating a variable. of the position. So we've got current X, current Y. This could be an object for, to be all intents and purposes, but we're just treating it as two variables for now. We're taking the player Y position and the X position by dividing by tile width, and because the registration point is in the top left-hand corner of those tiles, it will give us an integer, a whole number. So just get the calculator, and let's say, for example, okay, so if we have 0 divided by 64, then obviously that equals 0. That's the current Y when it's in that position. But if it's positioned at 128 divided by 64, then it gives us 2. What this means is we can tell exactly where it is within the array. We know its location because there are 10 values in each of the rows of the array. So there's 10 values in here. And so the location is 0, 1, 2, up to 9. So if we just take the calculator back again, and let's say 64 times 9. So the position of 576. 576 divided by 64 equals 9, as you've seen. So that means that when the player is positioned at 576 pixels, it will then correspond to where it is in that array. So all we're doing is turning, with a little bit of maths, it into a meaningful number so we can find its position inside of the array. In doing so, we can then reference it. We can then say to the left is current X minus 1, to the right is current X plus 1, to the top is minus 1, and to the bottom is plus 1. Now, for some reason, Flash doesn't have a problem, sorry, Animate doesn't have a problem with numbers that don't exist in the left object and the right object, which is in the arrays within the array. So it doesn't have a problem, say for instance, that if I say want to access the property of minus 1 from 0, and there's nothing there because it starts at 0, 1, 2, 3, it's not having a problem with that. However, it does have a problem with it here in the main array. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it throws a bit of an error if we are looking for a value of minus 1, rather than just returning undefined. So we handle this slightly differently for the left and right to the top and the bottom. Left and right, if it doesn't exist, we'll just return undefined. That's not a problem. Top and bottom, however, will return an error that breaks the whole script. So I handle this by saying that if the value for top Y, which is the position above it, is greater than or equal to 0, then we will look for the value in the map array as such. If it doesn't, then we won't, and it will be undefined. And if it's undefined, then we can respond to that. So the left object, right object, top object, bottom object that we've got here, what happens is we're just returning the value, as we've done before elsewhere for the map. So I'm looking at the map and saying, okay, to the left, there is a value. Where I am now, which could be 0 on the top row, and then the position to the left. And if we just test the movie, we'll see in the bottom corner here, when I move around, I've got some information. It's telling me that that's undefined 1, undefined 2. Going back to the code, what that's telling me is what I'm tracing out is the object. So it's the top, what's above, the bottom, what's below, to the left and to the right. We're returning this variable that stores all of that information when it's called. So then when we get to context object, what we've got is the player location context will return a value from the map. So it's like, okay, if in the map it's a 1 to the left of where I am, then I can move left. If it's a 1 to the right, I can move right. And if it's a 1 to the top or the bottom, I can move up or down. And how we approach that is based on the information we had before. And that is how it works. There's not really much change beyond adding in this line here into the move player, adding in this bit here to each of the conditions. And just a note about this, this is another operator, which is it's a logical operator. So basically what it says is and. This means that if the keyboard left is pressed and the value in context object left is equal to 1, then we can do this. Otherwise, if either of those are not evaluating as true, it will not happen. Okay, so that's where we get to in this session, and the new function is get player location context, which is there. Everything else stays the same, so we'll end at that point.